Hi everyone. So in today's video, which is our first video this spring, we are going to do a quick little overview again of class like we did in class, but I'm going to go over a few things again just so that everybody can just review what we talked about in class already on Tuesday. We're going to introduce some properties of alcohols as a review from Organic 1, and then we're going to go straight into acyl nucleophilic substitutions, but we're only going to focus on two types of nucleophiles first. I want to remind you that nomenclature is your responsibility, but I'll do a problem just to refresh ourselves on alcohol nomenclature from Organic 1, and then we'll keep looking at that. Now, this semester, just like last semester, we do have past sessions with your past tutor, which you'll go over to Edge Hall and have past sessions there. I will let you know as soon as those start. I will have practice session, and as usual, we have office hours, and those will be on the syllabus. So if you need to know when my practice session is or my office hours, please go consult the syllabus so that you know when I will be around. And lastly, we will also have other tutoring type sessions that are available to you through the school. And I believe those you have to sign up for sure. With the past, you do need to sign up, but if you just show up, just make sure that you check in. So as a reminder, you got your link for your Plickers. We use it for the first time in class. Make sure that you bring that link with you to class every day. So save it somewhere on your phone, your iPad, your laptop, your tablet, whatever device you would like to use for class. And remember, you'll get full credits as long as you submit your answer and it's correct, but you will still get points for submitting answers even if they're wrong. I just want you to engage and participate and try your best. So even though you won't get full credit, you'll get some partial credit for questions. If it's an opinion question or it's a survey type questions, those automatically get full score. Those clickers are going to be based on the previous content from either Organic 1 or things that we did last class or things we just talked about. They'll also be based on lecture videos, your reading. So please make sure you come prepared for class. That's why you do your lecture online, because it's easy to just go at your pace, take your own notes as you want to take your notes, and that you're not feeling rushed in class so that we can spend more time on the harder stuff, which is the problem solving. So please bring your notes to class. Next, just as a reminder about the videos, there'll be embedded questions in the videos. And so some of your points come from watching the video and some of your points come from answering the questions correctly. Some questions you can repeat as many times as you want to until you get correct. Some you only have one option to get it. So you want to make sure that you try your best to answer the questions. You'll also have a document that some questions that you'll fill out. That's called your muddiest points, and that's going to be based on what you've read as well as the video. So you're going to be answering for me a question, and you need to be as thorough as possible. These are to help me prepare for class the next day. So after you submit them on Mondays and Wednesdays at 10 o'clock, I'll review them, and I may revise my class based on what you said. If I don't need to revise it, I'll know things to emphasize. So be very, very specific. Telling me something like not applicable will not get you the point. So you want to be very clear. There's always going to be something that you don't quite understand. I also ask you what is the easiest points. So if there's something like you really got everything, you can also tell me what was the easiest thing for you, because that also helps me address things in class. So after 10 o'clock, I will revise the things that I had intended to do for class, look it over. So you must submit your assignment by 10 o'clock. Along with those videos, you will have some worksheets that you may fill out, mechanisms, handouts for the notes, so you can just download those if you'd like rather than writing everything from scratch. So bring those to class with you. But this will give you a chance to think about the content so that as we solve problems, you are not learning everything at one time and then having to be doing work at the same time. So take your notes, and you can review these videos as many times as you want after the due dates as well. And they'll be posted on YouTube after the assignment, so you can review them as many times as you want to go over anything that you might have missed through YouTube. Class. Things coming up is your first reading that's required, and then there's also an optional reading. Your quiz for the review of Organic 1 material will be due soon. The assignments and things like that that you need for Unit 1 are up, and some of the stuff for Unit 2 will be coming up over time. So you'll see things posted in advance. They're not going to be like the night before or a day before. They're going to be a bit of time before. Um, so one thing I want you to do is review things from Organic One related to how to make alcohols or how to use alcohols. I really suggest that you check announcements regularly. That's the only place that you will see certain things being announced. As well as I will have a weekly announcement with a reminder of everything coming due, all your assignments and things like that. I'm going to go over a few things of our setup of Canvas, and so you'll see an insert of a video coming for that. All right, on Canvas, a few things that I want to point out is that there'll be on the front page, there'll be weekly assignments. Sorry, not weekly assignments, but you'll see in the to-do, you'll see what's coming up. You'll see your weekly announcements. So if you click on them, you'll see in the last couple, but you can click on announcements. And I know this is the Organic One page, but for this class, it's going to look exactly the same. I just wanted to go under student view so you can see it. So you'll see, for example, one of our weekly announcements will look like this, and you'll see what's coming up. You'll see links to things that you can click on, so you'll always kind of know where we are. Every week I'll post this typically on Saturdays. If you want access to your textbook has a link that opens to another page. So I know this was a comment in one of my evaluations that outside of the assignments, you didn't know how to access your course. So to access the course, once you have your course integrated, you would just click on the textbook. So you would launch a textbook, or if you paid for the key, you would find the key there. And so you can find all the resources that you need associated with that course. So you can go through the course assignments, but you can also find it here. So I just wanted to point that out because I saw one of my comments in my evaluations was I didn't know how to access the textbook. So here it is. And that's where it will stay. It's always on the side. You can go to the different modules for the semester. And under the module, I want to point out that that's where most of the really critical information is going to be. So for example, if I go under module 1, I can get to it from the home page, or I can go straight to under module. I'll click on the module. There's always going to be a page that says Unit 1, assignments, resources, and this is where you're going to find a lot of the things that might be helpful to you. So please use these pages because I spend a lot of time putting them together. One comment that I know someone asked is that there were some of my due dates might not be quite the same when I copy things over. If you ever see that, please let me know. But you might see some of my documents with dates that are not today, this year or whatever. And that's because the assignment may not have changed, or it may have changed the link, but not changed the date right here. So don't worry too much about what these years might say. They're the same assignments, or they're updated assignments, but I did not change the name of the link directly. You'll also see that there are old videos that you can review, including there will be a mechanism video, If you click on the different tabs, it will take you to the different places that you need. So lecture, notes, so if you want notes or mechanism handouts, as well as the objectives for the course. You can find your grades, other people in your class if you want to contact them, if you want to do collaborations with people in your class, you can do that. So there's a bunch of stuff that you can do in here. All right, so we're going to do an introduction to this unit. But before I do that, let us review retrosynthetic analysis that we did in class, and then we're going to go into our next chapter. So to review retrosynthetic analysis, now that you've learned a bunch of different reactions, they mostly come under the category of addition, elimination, substitution, and radical reactions. So they're all kind of the same, similar types of things, except radicals are a little bit different. Now that we've learned some more, and we're going to be learning even more, they're all kind of related to what we've already learned. They're just different functional groups and different starting materials and things like that. We have to assess how is our carbon skeleton changing, and then assess specific things that are changing about it that we can think about. So we talk about if we want to add carbons. So far, the only way we know how to add carbons is through alkylation. And to break carbons, we know that ozonolysis is our only way so far. That doesn't mean that there aren't some more. We just haven't learned them yet. So as you learn these things, I would recommend making a little chart on how to make certain functional groups or how to do certain things and practice with it. You don't have to go it alone until you get to your test. The second thing we do is analyze functional groups, how they change, what kinds of things, and then you go to your little chart and you try and figure it out. So we talked about some of the tips, like how, first of all, what kinds of things make carbon-carbon bonds or break carbon-carbon bonds? What functional groups do we get from those? What are the only reactions that alkanes can do, which is the only thing is radical reactions as of this class. Remembering that certain groups are better than others at doing certain reactions. So for example, OH groups are not very good leaving groups. So if we want to do things with them, we usually tosylate them, mesylate them, or trifolate them first. Knowing that hydrogenation is something we learned last semester, but gets rid of all pi bonds. And so this semester, we're also going to learn about how to selectively get rid of certain types of pi bonds and not just all. And that's where we utilize some of the knowledge that we learned in Organic 1, like using hydrides, which can react with a partial positive of a carbonyl. That's actually what we're going to talk about in. Let's do a quick retrosynthetic analysis review question. And so on this particular question, I am going to try to make this molecule starting from this molecule. So to do my analysis, the first thing that I want to pay attention to is that I start with only 2 carbons, but over here I have 1, 2, 3, 4. And so I've gained 2 more, as well as now I have triple bonds. So I've gained 2 carbons. I also gained a triple bond, and notice the triple bond has 2 carbons. So thinking about Organic 1 and thinking about what can I do to do this retrosynthetic analysis, I know that I can add an alkyne. So I would start with an acetylene or ethine. Then I'm going to add sodium amide to it. So that would be step 1 to make my amide ion. Sorry, my dog is barking. All right, so now that we have that, I remember from Organic 1 that I can do an alkylation of an alkyne, so I can actually do that reaction and get the product. So that was a quick and simple problem, but let me complicate this problem and say I want to make an alkene from this molecule. So I would have to think
a little bit more carefully because I can't just do an alkylation of an alkene, but I can use the same idea. So this is going to take us even more steps, but it would be the same idea. So I'm adding 2 carbons and I'm including an alkene, but I know that alkenes can be made from alkynes. And because I know that, I can use the same process. So I know, and I need my retrosynthetic arrow, that if I took my ethine, react it with sodium amide, I can get my ethylene. From my ethylene, I can take my alkyl halide, react it with the acetylene ion, get my alkyne. And then from there, I can do one of 2 things. The easiest one is hydrogenation with a poisoned catalyst, specifically the one that we're more aware of is Lindlar's catalyst, and so it's hydrogen gas. We can do any of the other poison catalysts. We typically, most students don't remember the other ones, so that's why I typically don't talk too much about it, but Lindlar's is the most common one. That's the one that we see
in the second half. So one of the things you want to do is review things that start all the way from Gen Chem, and particular things from Organic 1. And one of them is properties of alcohols. It's very important to understand that with alcohols, because they have the OH group, one fundamental thing about them is that they can undergo hydrogen bonding. So specifically intermolecular attraction that makes them undergo hydrogen bonding because of the electronegativity difference between oxygen and hydrogen. That causes most alcohols to have high boiling points, high melting points. But one thing I want to point out that's something we probably haven't talked too much about in some of your previous classes is the OH groups will give hydrogen bonding, but it also depends on how many carbon groups are on there that affect the molecule. So if you have too many long carbon chains, or your shape of your molecule is kind of bulky, it will impact the ability to hydrogen bond. And if you impact the ability to hydrogen bond, it may not be as sticky with each other. And so if you had like 20 different carbons on a chain but one OH group, the carbon chain is going to dominate. So typically for every 6 carbons, that OH group might dominate. So if I started having 7 or 8, the OH group is not going to be as dominant in terms of the intermolecular force, but van der Waals or London dispersion force is going to dominate a little bit more. So we're going to do a quick problem on naming alcohols, but remember nomenclature